This tutorial. So this is about stress and strain. So now here it is deal with what is stress and what is strain. So first here need to see the what are the assumptions need to take in strength of materials. So what are the assumptions that we need to take? So here you can write assumptions 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 in strength of material. So while we are dealing with assumptions, so first assumptions that we take in strength of material is material subjected to external forces. Material subjected to an external forces forces is assumed to be perfectly elastic. Is assumed to be perfectly elastic. So this is a first assumptions that need to consider. Next is second assumptions that what it deals with, that materials are isotropic. Materials are materials are isotropic. Isotropic means same properties in all directions. Same properties in all the directions if a point is considered within a material. So next third point that deals material is homogeneous. Material is homogeneous. It means same properties anywhere within the material. Same properties anywhere within the material. So this is the assumptions that material should be perfectly elastic, material should be isotropic and homogeneous. So now we'll go for what is the stress. Now we start with dealing stress, and its symbol is generally we write sigma. So here how we are going to define the stress. So the forces tends to deform the body and causes. So we can write the forces tends to deform the solid body and and causes it to develop equal and opposite internal forces. Equal and opposite internal forces. these internal forces these internal forces internal forces by virtue of cohesion by virtue of cohesion between particles of the material of the material of the materials tend to resist the deformation. The deformations. It means if force is applied on a materials, what happens? Suppose this is a member. This is a member which is undergoes, which is experience a load at both the ends. Let's take a section that is XX. What happens? What happens? That sections we are taking. So load is being applied here. That is P. Tensile force is applied, and another sections that we are taking. So what happened? That first load. This is the load here P. This is load here P. So against this load, internal forces will develop. So here internal forces will develop. Same way on this member also internal forces will develop. And let us say this is a section that we have taken XX. So this phenomena that happens, and it happens over a cross sectional area. Okay. So now what we can say, that now segment of members is in equilibrium under, now segment of member is in equilibrium, under the action of force P and the internal resisting force, So what will happen? That internal resisting force per unit area of the surface is known as intensity of a stress or simply stress. So here now we can see the resisting force, per unit area of the surface is known as intensity of stress or stress. So this is defined. So how we can write? So suppose the cross sectional area, this area, cross sectional area where load is being applied, and so how we are going to balance this? So load is equal to P. Okay, and consider this load is uniformly distributed over cross sectional area. So this is considered. So cross sectional area is equal to A. Stress is equal to sigma. So stress equal to that resisting force per unit area. So here always we say resisting force per unit area over and cross section. Okay. Then if the intensity of stress is not uniform throughout the body, if intensity of stress not uniform throughout the body, then what will happen? So we'll consider number of small points, and that can be defined sigma is equal to delta P by delta A. Means that load is not distributed uniformly, means at every point we have different loading conditions. So at a small point when we are going to define the stress, so this is defined as sigma is equal to delta P by delta A. Here delta A is called as infinitesimal area of cross section, and delta P, that is called as load applied and area delta A. Load applied on an area delta A. So next we will see the proof stress. So what generally proof stress is? Proof stress. So it will define how it is defined. The stress at the elastic limit. The stress at elastic limit. So up to elastic limit, whatever stress we are getting, that is called proof stress. So next see the unit of stress, that called Newton per meter square, or we can say Pascal, or you can denote it as PA, or you can say megapascal. These are the units, or gigapascals. So it has conversion that easily we can convert, like 1 megapascal, that it is equal to 1 Newton per mm square. If 1 gigapascal, that can be written in as 1 kilonewton per mm square. So like this we can define these terms. So now up to here, let's stop this session. Thank you.